First thing you need to do in this video is please go ahead and label all your shapes. So if it's quadrilateral, then we know the next shape is a pentagon, and the next shape would be a hexagon. And so go ahead, pause the video, and finish those. All right, and then your next step I would like you to do is obviously go measure the sides. Just be careful. We know this has 5 sides, this has 6 sides, this has 7, 8, but be careful. We skip to 10 sides. And the thing I want you to realize is it is a heptagon, which is 7, not septagon. Sometimes people think that's 7. So just be careful. A 7 figure is a heptagon. The next thing I would like you to do is construct diagonals, and you'll see what a diagonal is a segment that connects non-consecutive vertices. So this is not a diagonal here and here, but this is, and this is. And I would like you to construct diagonals from only one vertex. So here I can construct 2 diagonals, and then from here I can connect that, and that's 3 diagonals. So it is only from one vertex. So go ahead and figure out, pause the video and finish that. Next thing I want you to do is realize how many triangles there are. So if you look at the quadrilateral, there's 2 triangles that are made after the diagonal. So one of your triangles is here and one's here. So that's where they're getting this number. It's the number of triangles. So in this one, you'll see there's 3 triangles here. You'll see that you make 4. Remember, this one's 4. You're going to see you're going to make 5. You're going to make 6. And you're going to make 8. So obviously, you can figure out that there is a little bit of a pattern. Next thing we need to notice is this. If it has 5 sides, okay, it has 3 triangles. If it has 6 sides, it has 4 triangles. 7 sides, 5 triangles. 8 sides, 6 triangles. And then we notice if it has 10 sides, it's 8 triangles. So if you look to try to discover what the pattern is here, if you have a figure with 12 sides, I know that -2 is going to get me the number of triangles. And if I take that number and I multiply by 180, that's going to tell me how many degrees is in it. So 10 times 180 gives me 1800 degrees. So if I go back to these, you can see that if it has 3 triangles, 3 times 180 is 540. 4 times 180 is 720. And so if it has 7 sides, it makes 5 triangles. And 5 times 180 is 900. And 6 times 180 is 1080. And 8 times 180 is 1440. So that is how we find the interior sum of every single polygon. So what is an interior sum? It is the total amount of all the angles values added up. Something you need to know is that all these polygons, the only way we can do this is if the polygon is convex. Meaning it does not cave in. So I cannot find interior sum of a concave polygon, only convex. So when we did the 12 one, the formula is 12 minus 2, get us the number of triangles. That's going to be 10. 10 times the amount in a triangle. And that's how I'm going to find the interior sum. So if I need you to write an expression for the sum of the measures of the interior angles of a convex polygon, this is what it means. For every interior, we can take n, the number of sides, sum of the interior, equals the number of sides minus 2 times 180 degrees. So if in number 3, so if I gave you an 18-sided figure, how much degrees is inside that? We would take 16 times 180 degrees and whatever that is. So it's 16 times 180, 2880. So 2,880 degrees. This type of question I might give you is, what is one angle? What is each angle inside a regular polygon. And here's the thing, you have to know what the word regular means. And regular means that it is a polygon that has all equal sides and all equal angles. So obviously in a triangle, it has 180 degrees. So if I take that 180, but I divide it by 3, then I know every angle inside 60 degrees. In a quadrilateral, we know the inside's 360, and if I divide it by 4, then I know every side's 90 degrees. This is only if it's regular. In a pentagon, I know it has 5 sides. I take away 2 times 180. It tells me it has 540 degrees in it. And then I'm going to divide it by 5 to find one interior angle. So 540 divided by 5 is 108. Okay? And then your heptagon and your decagon. So pause and go ahead and do that. So you'll see here 1440 divided by 10 gives me 144. And it's okay that it comes out not even because sometimes it won't. So heptagon, each angle's 128. Last thing we have to talk about is the relationship between every polygon's interior and exterior. So if I take a triangle and I know, let's say that it is regular, meaning basically equilateral. If you know this is 60, you have to realize you have to be able to find every exterior angle as well. So if this is 60, we have to know that the exterior angle has to be supplementary to the interior. And that is true in any polygon. So if we take a look here, right? Any polygon, if you know the interior's 30, then you absolutely would know the exterior's 150. Well, if you take a look at this, if this is 120, 120, and 120, 120 times 3 is 360. Well, if I do a rectangle, okay, or a square, whatever, and I know all these are 90, well, all the exterior here would be 90 as well. Well, 90, 90, 90, 90 is 360. So now I have two shapes which the exterior is 360. So if you look at this here, you'll see here, for example, if this interior right here was 65, its exterior is 150. Well, every exterior angles will go down to 1 revolution. So it will not matter what shape it is. Every polygon's exterior angles, if you look at this, the exterior angles of any polygon add up to 360, as long as it's convex. Concave, we can't do this. But same thing here. This one had 5 sides, 5 sides. This one has 6 sides. If it's shrunk, it's also going to go down to 1 revolution. So when I ask you this question, which I think is the hardest question I can ask you out of all of this, if a regular polygon has an interior angle of 150, how many sides does it have? So one thing we have to realize, it's regular. So if I was to draw a polygon, we don't know how many sides it has. But if I know one of the angles is 150, that means they're all 150. But it doesn't, I don't know how many sides. But if the interior is 150, I know the exterior has to be 30. Interior, exterior. Well, if I know the exterior is 30 and I know that every polygon's 360, if I take 360 and divide it by 30, then I know it has 12 sides. Okay? Does that make sense? So any polygon, 3 sides, 4 sides, 5 sides, 6 sides, 7, 8, 9, 10, exterior angles always add up to 360. If I want to find one of them, I would divide by the number of sides. If I want to find how many sides, I divide by the number of angles. I'm going to bring you to the practice real quick. If I want to find the sum of the interior. This is sum. This is a big number because sum is large. And the smallest sum we can ever have is 180. So we know our answers have to be bigger than 180. Decagons 10, so 8 triangles, 8 times 180, we know it's the 1440. If I ask you for the number of degrees in each angle, it's going to be smaller. Pentagon, 5 sides. 3 times 180 is 540. But then I need to divide by 5, and I think it's 108. If I give you the total degrees, then I know 1260 has to equal n minus 2 times 180. Now, you can distribute this, but I'm not going to do that. I'm going to divide by 180 and get n minus 2 equals 1260 divided by 187, and I'm going to add 2. So if it has this, it means it has 9 sides, which means it's a nonagon. And then let's look at this one. 3 angles in a hexagon are this, this, and this. Well, first of all, we need to know what shape. Hexagon, which means it has 4 triangles at 180. So 4 times 180 tells me its total 720. Well, if you know one angle is 150, one's 160, and one's 218, that's kind of silly that can't happen. But we're going to pretend. So 150, 160, and 218, we're going to say that it's 528 plus the other 3 angles. So basically this is giving you this, and it's saying this is 150, 160, 218, which can't happen, but that's okay. And then 2x, 3x, and 7x. So when I add these, it's going to be 12x. Finish it, go from there. This is exactly your problem from the note sheet. Each interior is 120. You need to find the exterior. When you get that, take that number and take it 360 and divide by that. Okay? So work through these. All right. I'm just looking at this one. Find the sum of the interiors of a pentadecagon. Please know pentadecagon. Okay, so I'm going to take 13 times 180 to get the number. So I know it's 2340. If I divide it by 15, that's going to get me each interior angle, which is 156, but it asks for exterior, which means I need to take 180 minus 156. Now, that's an extremely long way to go about this problem because this is why. If I want one exterior angle, I know every single polygon. Doesn't matter if it has 15 sides. Its exterior is 360. So if it has 15 sides, I take 360 and divide by 15. My answer is 24 degrees. So that would be a much easier way. So go ahead and work through these and see how well you do. Thanks, guys.